This is the very first section of chapter 9. And on this section, we're going to be graphing parabolas. What is a parabola? It's a U-shaped curve. We already know what a standard form quadratic trinomial looks like. A is the number in front of x squared, bx plus c. We've been factoring these types of guys, right? We already know that if the a value is something like 6, it's a little bit more challenging to factor if it was 1, than if it were 1. So if you had a 6, you would have to go a times c, get an answer, think of the multiples of that answer, that combined together to give you b. We've already factored, we've been dealing with standard form quadratic trinomials for a while now. Okay, and what does it say here? It says up until this point, we've only graphed lines. I hope we remember y equals mx plus b. Today we'll begin to graph parabolas. What are parabolas? They're U-shaped curves that either open up or down. Okay. The most simple parabola would be the function y equals x squared. We can graph this function just like any other function by using an xy table. So everybody please follow along with me on your paper. What we're going to do is make a quick xy table right below our function y equals x squared. By the way, this is the simplest parabola that you could graph. It's actually called a parent graph. What do I mean by parent graph? Because all other parabolas are in some sort of way related to this parent graph. They all kind of look like this U-shaped curve. So using the xy table back when we had lines, we just plugged in any 3 simple numbers like 0, 1, and 2. Let's do a little bit more than that on this one since it's our first time. Let's plug in 0, but put in 0 right in the middle, not at the top. Don't put it 0 up here. Let's put 0 right in the middle. And then after that, let's plug in a 1, and then a 2, and maybe even a 3. And let's also do -1, -2, and -3 this way. That way it's in consecutive integer order. Now, if I do plug in a 0, remember our inputs, if I say plug in, I'm talking about my x values. After all, it is on the left side where the x's are at. My inputs are my x values. I want to input this 0 into the x. What is 0 squared? 0. 0 times 0 is 0. So for my input 0, I get an output 0. Let me plug that in. Let me graph it. So everybody should put the dot right there at the origin. Now let's plug in the number 1. When I plug in the number 1, what is 1 squared? 1. And let's graph the coordinate 1, 1. And now let's plug in 2. When I plug in 2 right here, what's 2 squared? 4. And let's graph the coordinate 2, 4. So when I graph, I go at the origin, I go 2 on the x, 1, 2, 3, 4 on the y, and I put a dot right there. And last but not least, let's plug in the 3. And when I go 3 squared, I get 9. So let's graph the coordinate 3, 9, and it'll be way up here. Now, if I did plug in a -1 right there, what's -1 squared? What's -1 squared? What is -1 times -1? -1 times -1 is? +1. Okay. How about -2 squared? What's -2 times -2? +4. What if I want -3 squared? What's -3 times -3? +9. So for the sake of time, let me just map those coordinates on there. So there they are. I mapped them in blue just so you could see. And just like you mentioned right now, this is like a perfect mirror reflection, right? So let's actually draw a vertical line going right through the center of this parabola. I might be getting a little ahead of myself. I am. This little vertical line that we're drawing, I do it dotted. It's called the axis of symmetry. What does symmetry mean? Same on both sides, right? Perfect reflection on both sides. And that's what this does. This axis of symmetry, it cuts it perfectly in half. If I were to take this paper, if it were a paper, and I folded it, then this dot would land perfectly on top of that dot. This dot would land perfectly on top of that dot if I were to fold the paper right through this axis of symmetry. So it does provide a perfect mirror image, a perfect reflection across this axis of symmetry. So that's a vocab word that we definitely need to know, the axis of symmetry. And we are going to have to find out how to write the equation of this axis of symmetry. By the way, what is this axis of symmetry? Is it vertical or is it horizontal? It's vertical. And any vertical line, like, okay, this is totally off topic here, but it's kind of like a review. Like, let's say I drew a vertical line right here going through 8, like that. So this has nothing to do with the actual graph, but that vertical blue line right there that's crossing through the axis, or through the x-axis at the value 8, is that the line y equals 8, or is it the line x equals 8? X equals 8, right? It crosses the x-axis at 8, and that's why it's x equals 8. So this vertical line, it has the x equals, right? Any vertical line has x equals. Okay, so keep that in mind. Any vertical line has x equals. We'll get back to that later. So let's go back to the parabola. We haven't even finished graphing it. We have the coordinates. Let's graph it now. We're going to draw a perfectly continuous line right through it, touching all those coordinates. And we put arrows at the very end. Okay? Now, why do we put arrows right there? Let me put all the coordinates in blue. Because it continues forever, right? So what do I mean by it continues forever? The coordinate 3, 9 is not the last coordinate. There's more coordinates up here somewhere, right? If I wanted to, I could input the number 4, right? If I inputted 4, what's 4 squared? 16. So technically, let me actually write that down right here. 4 comma 16, that's also a coordinate. So if I went 4 on the x, 1, 2, 3, 4, 16, here's 10, 11, 12, 13, 14, 15, 16, maybe up here. That coordinate is still part of this parabola. It's just off of the graph. Make sense? Okay. So how about this? For my input 10, and let me show you a little bit more zoomed in. For my input 10, what would my output be? Obviously, it'd be way up here off the page. But what would my output be for my input 10? 100, right? Plug in 10 right here, and 10 squared is 100. So this parabola really does continue. Even though it looks like it curves, even though it looks like it curves up, it never goes straight up. It continues this way forever, and it also continues this way forever. Okay? Because you could plug in any number you want for x, and you could square it, and you get a super high number for y. Make sense? And that'll come into play when we start talking about domain and range later on. Anyhow, let's continue with these notes. As you can see, when you plug in a negative number, you still get positive answers, because when you square a negative number, you get a positive answer. Now let's go with the vertex. The vertex is a coordinate. Very important word, vertex. You have to know what it means, and you have to be able to calculate the vertex. The vertex is a coordinate. It's a location on the xy plane. It's either the highest point or lowest point of your parabola, depending on if the parabola opens up or down. So here's a very important fact that we need to understand and have in our minds always. Okay, good. Yeah, good point. Up here, your vertex, since we said the vertex is either the highest point or the lowest point, 0, 0 is the vertex for this parent graph of y equals x squared. Perfect. You guys got it. Here's a very important fact. If the a value is positive, it's going to open up. If the a value is negative, it's going to open down. Yeah? Okay. So this parabola opened up, which means that the a value was positive. What is the a value right here? 1. It's 1. It's positive 1, right? If this would have been negative 1, then it would have opened down this way. Okay? So any a value that's positive, you know it's going to open up. Any a value that's negative, you know it's going to open down. Now, why is that important if we're talking about vertex? Well, if it opens up, then you have a minimum value. If it opens down, you have a maximum value. I'm talking about your a value. So like, let's say, let me just write down a random equation here. Y equals negative x squared plus 3. I don't know, something like that, right? And I asked you, is this going to have a maximum vertex value or a minimum vertex value? What do you guys say? It's opening down because the a value is negative 1, you know it's going to be opening down, so you know that it's going to be a maximum vertex value. Got it? what is the maximum mean? That's a ball or whatever. Doesn't matter what it is, right? It's a black dot. Okay. So if this guy throws a ball up in the air, it's going to go up, up, up until it reaches a maximum height, and then it's going to come back down, right? So that itself, if you do throw any object up in the air, it's naturally going to go in the path of a parabola. Okay, that opens down, which means that it reaches a maximum height. So your vertex here would be a maximum value. Okay,
So that's the highest it can ever.
the highest it could ever go. Now, if you were on a swing or something like that, or maybe you're bungee jumping, right? Bungee jumping, you come down, you bounce back up, then that would be a minimum value because the parabola opens up. Okay, so the A value tells you indirectly if you have a maximum vertex or a minimum vertex. Because if the A value is positive, it opens up. If the A value is negative, it opens down. And if you know that it opens up or down, you'll know if you have a minimum or a maximum value. Okay, so that's just like, it's good to know, but what we really need to mathematically calculate is how to find the location of that vertex, okay? Now, how do we find the location of the vertex? Using the vertex formula. Guys, we have to memorize this formula right here, the vertex formula. X equals negative b over 2a. Again, x equals negative b over 2a. Say it over and over. Negative b over 2a, negative b over 2a. Now, when you use this formula, just like any other formula, please use parentheses before plugging in your values. So when you use this formula, go x equals negative b over 2 times a. Okay, that's how you're going to use it. Now, there are no examples right here on your on your notes, but I just I typed some in right now so we could work on practicing finding the vertex. Okay. So maybe, I know you don't even have that much space. Maybe you want to write them on a separate sheet of paper. Let's take a look at number 1 right here. Let's practice finding the vertex. So once again, this is a standard form quadratic trinomial equation. We've been factoring these guys for the past 4 or 5 weeks, right? But we know that the A value is 1, the B value is negative 2, and the C value is negative 4. Now, let's write down the vertex formula. Okay, guys, I repeat, this is not on your worksheet. I'm sorry. I should have put it on your worksheet, but I'm sorry. I just typed this in right now on this video. I want you guys maybe to write it down on a separate sheet of paper, or maybe if you have a little bit of space, at least copy one of these down. I'll do 4 of them, but I want you to copy at least one of them down. So I just made this up. Y equals x squared minus 2x minus 4. Here is the vertex formula that we have to have memorized. How do we use this guy? We use it like this, with parentheses. Okay? And now let's plug in our B value. What's our B value? Negative 2. So let's plug in a negative 2 right there. And what's our A value? What's our A value up there? 1. So here is our values plugged into our formula. X equals negative negative 2. So what does that mean? Negative negative. Changes to plus. Positive, right? So we really have x equals 2 over, what's 2 times 1? 2. So what does x really equal? 1. Now, ladies and gentlemen, we said a couple of moments ago that a vertex is a coordinate, an x and a y value. So what did we just find? We found x. So you plug in that x value right here. That's half of what you need so far for the vertex. Now, how do you find the y value if you already know the x value? How do you find the x value if you already know your y value? You plug it into your equation, right? I mean, we've always known that. Let's go back to the beginning of algebra. Remember, we had x plus y equals 5. If I told you, hey, y equals 1, find x, what would you do? You plug it in, right? And then you could solve. Okay, so that's totally random. But anyway, whenever you have your x value and you want your y value, all you have to do is plug it in and solve. So we're going to plug in the 1 into our equation, our original quadratic trinomial equation. Now, guys, again, when you plug in numbers, use parentheses. So the best thing to do is to go back to your original and rewrite it, but instead of the x's, put parentheses. So y equals parentheses squared minus 2 times parentheses minus 4. And what are we plugging in right here? What's the x value? The x value is 1. You can see it right here. So let me plug in a 1 right here and here, and let's work it out. Now, man, this is ugly. It's all crammed. But we could do it. What is 1 squared? 1. And what is negative 2 times 1? Okay, so I have 1 minus 2, and then we have a minus 4 at the very end. 1 minus 2 minus 4. What is 1 minus 2? Negative 1. And what's negative 1 minus 4? Negative 5. So ladies and gentlemen, we found out that the y value, because that's what this was, y is negative 5. And ladies and gentlemen, we have found the vertex. Now this right here, this location on an xy plane, is it the highest point or the lowest point of this U-shaped curve? Is this chord, like, okay, if I actually go on a xy plane, if I go to the coordinate 1, negative 1, 2, 3, 4, 5, and put a dot right here, that's my vertex. I know I'm going to have an axis of symmetry going right through it. But is that point the highest point or the lowest point? Wait, this is the highest. This is the lowest. What do you guys think? How do you determine?
No, because go back to your equation. And
Here's the equation.
Yeah, that's your A.
And your A value is positive, right? So if it's positive, it opens up. If it's negative, it opens down. So knowing that it's positive, you know your vertex is an actual minimum value. Okay, your vertex is a minimum value. I know you guys don't have space, but work with me here. Again, the formula is x equals negative b over 2 times a. Yeah? Okay, so what is my b value? Negative 4. What's my a value? 1. So on top, I have positive 4. On the bottom, I have positive 2. So what do I get? 2. So your vertex is a coordinate, and we end up with 2 for x. Now, you want the y value, all you have to do is plug it in. So what I'm going to do is I'm going to rewrite this equation, but instead of x's, I'm going to put parentheses. Now remember, we are plugging in the x value of 2 that we found with the formula. So let's plug in 2 right there and 2 right there into the x positions. When we do the math, 2 squared is 4, minus 4 times 2 is 8. Bring down the plus 3. 4 minus 8 is negative 4, and negative 4 plus 3 is negative 1. So right here with this work, we just found out that my y equals negative 1. So there's my y value of negative 1. So the vertex is 2 comma negative 1. This is the very first skill that you guys need to know on this section, how to find the vertex of a quadratic trinomial function, right? Should we try another one? Yes. All right, let's try another one. Number 3. How about you guys get a piece of paper out and try to do this right here. Find me the vertex of this guy. You will begin using the formula. The appropriate way to use any formula is to replace your variables with parentheses so you could have a place to plug in your values. You need to identify A, B, and C. So your B value goes up here, and your B value happens to be negative 8. Your A value goes down here, and your A value happens to be negative 2. So we're going to end up with positive 8 over negative 4. So what does that equal, positive 8 over negative 4?
Negative 2.
Negative 2, thank you very much. So what did we just find right now? We found the x value of our vertex. So if we're trying to find the vertex, we first need to remember that a vertex is a coordinate, which is really an x value and a y value, and we just found the x value of negative 2. If I want the y value, what must I do? Plug it in. So let me rewrite my original equation. Oh, you know what? I forgot a y equals. My bad. Well, it still works. I mean, so this is supposed to be y equals? Y equals. Let me rewrite that equation, but let me replace the x's with parentheses. And let me plug in that x value of negative 2 right there. and also over here. And now let's do some math. PEMDAS is always in effect. Start with exponents. Negative 2 squared, that's positive 4. But we still need to multiply it by that negative 2 out in the front. So let's put that negative 2 out in the front. Might as well rewrite the whole thing. Minus 8 times negative 2 minus 8. So let's do the multiplication next. We have multiplication here. What's negative 2 times 4? Negative 8. Okay, and what's negative 8 times negative 2? Positive 16. And let's bring down the minus 8 at the very end. So when I combine negative 8 and positive 16, what do we get?
8.
We get 8. Interesting. And then bring down the minus 8. What's 8 minus 8? 0. So the y value is actually 0 right there. So the vertex is negative 2, 0. So let's just see if we have an understanding. If I were to go to an xy plane, and if I go to the coordinate negative 2, 0, it would be right here, huh? And that would be the vertex. Now remember, the vertex is either maximum or the minimum value. So what do you guys think about this? Is this parabola opening up or down? It's opening down. How do you know it's opening down? The a value is negative 2. It's negative, so it must be opening down. So you could, like, if it's a multiple choice test, you already know that it kind of looks like that. You'll be able to identify it knowing the vertex and knowing if it opens up or down. And yes, this vertex is called a maximum.
What if x equals 0?
What if x equals 0? Then all that would mean is that on your xy plane, your x value would be 0.
No, but like, would it go up or down?
No, well, you're talking about your a value. Your a value determines if it opens up or down. Okay, now if you're saying if a is 0, then it wouldn't even be a parabola. You know why? Because 0 times x squared would be 0, and then you'd have back to the linear y equals mx plus b. Yeah. So yeah, a can't be 0, or else the parabola is no longer a parabola, it's just a line. I just want to practice one final one, and again, I messed up right here. This should be a y equals that stuff. So let's find, how about even before doing any math, does this parabola open up or does it open down? It opens up. The a value is positive 1. Knowing that it opens up, we already know that the vertex is going to be a what value, max or min? If it opens up, it's going to be a min value, that's right. Let's find that minimum value. And any test or quiz, they could tell you find the vertex, or they could tell you find the max or min value, right? It's the same thing. How do you find that? Use the formula x equals negative b over 2 times a. And when you use this formula, let's put parentheses instead of your b and a values. Let's identify that your a is 1, your b is 6, your c is 2. Plugging in 6 for b, plugging in 1 for a, we will get negative 6 over 2, which is what? Negative 3. So we have just found, remember the vertex is a coordinate, we just found the x value of negative 3. Now let's find the y value of that vertex. How are we going to do that? We're going to simply plug it into the original equation. I'm going to rewrite this equation, y equals x squared plus 6x plus 2, but I'm going to write it with parentheses instead of x's. There it is. Y equals x squared plus 6x plus 2, but with parentheses instead of the x's. Now I'm going to plug in my vertex x value of 3 right there and over here. Actually, it's negative 3. So when I do plug it in and I do the math, PEMDAS always start with exponents. Negative 3 squared, that's positive 9. Bring down the plus 6, bring down the times negative 3 and the plus 2. After that, we're going to do multiplication. Here's multiplication. What's 6 times negative 3? Negative 18. So we really have 9 minus 18 plus 2. What is 9 minus 18? Negative 9. So we have negative 9. That gave us negative 9 plus 2. What's negative 9 plus 2? Negative 7. So with this work right here, we found our y value of the vertex, which is negative 7. So the vertex itself is negative 3, negative 7. Those are just numbers that I created. It's not even on your handout. So I wanted to make one specific video just focusing in on vertex. And the vertex is the most important point of a parabola. It tells you whether it's the highest point or the lowest point of the parabola. Not only that, I mean, you need the vertex whenever you graph. So we're going to pause right there, And on the next video, we're going to start graphing parabolas. We're going to use the vertex by doing the formula, graphing the vertex, and then we're going to find the rest of these points on the next video.